Welcome to this talk. I hope you enjoyed your break. I've actually been part of this committee of this conference for a couple of years. This is actually the first time that I'm giving a talk. I hope you enjoy it. In case you're wondering, what do? I sell socks for a living. Well, not really. I just learned a new joke, especially for the locals. I work for Specsavers as a site reliability engineer. This is a joke just that went around earlier. Anyway, so I actually work for this company that sells socks, among many other things. It's in the fashion industry. It's a relatively large organization, exclusively working in the European market. This is probably not the most interesting thing for the SREcon. What is most interesting about it is the kind of work that we do, because we have a large engineering group with these tech hubs all over Europe, and I am actually in the headquarters in Berlin, and I'm working in the SRE. Today's talk is something that we've been working on for the past 2 years. And for me to get to the point, I need to take us all back to set some context, to set the stage. I don't know how many of you were lucky enough to be working in this industry for 2 decades or so, and were lucky enough to start working with a monolith. Long time ago, we were running monoliths. Monoliths had a couple of advantages. For one, they were running on a single box, and they were very easy to reason about. Requests would come in, responses would go out, and that was it. When it came to monitoring, this was also relatively simple and straightforward. This is also the time that we had the ops and the dev silos. This is very important. The ops people, they would monitor the hardware, they would check is the box alive, they would check if the process was alive, and this was the part of the job, while the devs would probably look at, are the requests flowing, are they eventually successful? This was if we were already lucky. Are they successful? This was pretty much how things worked back then when it came to monitoring. It's reasonable to say that this did not go well for long. The industry evolved at a very fast pace, and as organizations scaled, this became impossible to maintain forever. So we had to come up with a solution for this, and we did. The industry came up with a solution for this, and we came up with microservices. This is not another talk about microservices. I don't want to bore you to death, but it is important for this context. We went from this monolithical architecture to this modern microservice architecture, and I did mention how we were monitoring things, how we were monitoring the monolith. So this is just to explain the complexity and the explosion, but I'm going to try to make it more concrete. And then we're going to work on this concrete example as we evolve. This is an example of a very typical e-commerce operation, which is when you go and press the Buy Now button, when you place the order. If you are working in e-commerce, it may be slightly different. It may contain some of these, it may not contain some of these, but I think it is a fair demonstration of the complexity involved on such a simple thing as placing the order. This is actually simpler than our own. I may have anonymized some of the components. This is typical setup, as I said. All of these things belong to different teams, or at least multiple different teams, and this starts getting close to the core of this talk. How are we monitoring these things nowadays? How do you think that we are monitoring such a complex system nowadays? We came up with new roles and new names. We call them DevOps. We may call them SRE. The name doesn't matter. We may even call them cupcake fairies. Doesn't matter. Because at the end, what we ask now this new role to do is the box alive? Bless you. Is the box alive? Is the process alive? Is it serving requests? Are they fast enough? We're actually doing exactly the same thing. So in a way, we are just now monitoring a distributed monolith, but we call them microservice because it's fun. What is the problem with these things? I'm very confident that all of you experience something like this. You work for this organization, you are the service owner of one of these things, and eventually this accounting service has an outage. What do you all think happens when the accounting service has an outage? Who gets paging alerts for this? 1, 2, 3, 4. This is an exaggeration, but I think it makes the point. Everyone gets one. Everyone will get paged. Everyone involved in this thing will get its own share of alerts. Everyone will be on call. We'll wake up eventually. And the first 20 minutes are not to solve the problem. It's just to figure out who else is here. I call this effect the Christmas tree effect. There are a lot of similarities, a lot of blinking lights. Differences is I don't think anyone is happy. And I'm very, very sure no one is getting any presents. This is the actual problem. This is the problem that I think we are coming up with something. The solution, or a great part of this solution, is not new. This goes all the way back even to when the first book was published and there was an old chapter proposing to alert on symptoms instead. The industry figured this out. We should be alerting on symptoms instead of all of the possible root causes. And this would be another talk entirely, which, by the way, I tried to propose, but it was redundant. So if we already accept that we should be alerting on symptoms as a means to solve this problem, well, we just do that and problem solved. Or maybe not. So if we did alert on that thing based on a symptom, which is that is a good example where the signal-to-noise ratio would be ideal, then we would be alerting our customer successfully placing the order. And we put an alert rule there, where the signal-to-noise ratio is ideal. In this particular setup, what happens when the accounting service again has the outage? This time, only a single alert is triggered. And this looks much better. We eliminated the Christmas tree effect. But what would happen if the payment service had an outage? Would there be any difference? Not. Again, a single alert triggered. This is looking great so far. But there's something desperately wrong with this. Who's getting this page? The exact same team, probably owning the symptom or owning the client-facing services, is getting page bombed and is getting their 24/7 health completely destroyed by this approach. And this is the root problem. We need to move to symptom-based. For all of the reasons that the industry already understood, it is what we should be doing. But the technical means to enable that successfully, it's something that is still, to the best of our knowledge, not really settled. Very timely, there was a discussion on Twitter a while ago when we were already doing this that got to the bottom of this problem. In these microservice organizations with distributed teams, who does this triage? Who figures this out? Do we put someone at the front doing this alone, AKA bringing back the knock, something like that? Or do we keep the Christmas tree? What is it? And Charity actually immediately understood that's correct. This is a big problem. We are still not solving this. And this was in April this year. I think we came up with a solution for this problem. Not going to claim that it's the only or the best solution for this problem, but it's certainly working very well for us. We call it adaptive paging. And adaptive paging is basically an alert handler that you can plug into different alerting systems. But this one in particular, it leverages the causality from tracing and the strong OpenTracing semantic conventions to page the team closest to the problem. It is very similar to what we were doing before. It depends on alerting on symptoms. The difference is there is no owner of the symptom. Before I start explaining exactly how it works, a bit of a disclaimer. This depends on distributed tracing. We did this based on OpenTracing because it gave us everything that we needed in an open standard. And for those that may not be familiar with it, OpenTracing is just a set of vendor-neutral APIs that allows any application to be instrumented and ship tracing data to eventually a vendor that collects and visualizes the tracing data. Another part of the disclaimer, we also know that in the meantime, OpenTracing has joined forces and got merged with another instrumentation standard, OpenSensus. So very, very soon, all of this will be called OpenTelemetry. And this will actually be backwards compatible. So all of the constants that I'm going to explain afterwards, they are still valid. The span context is still valid. How the context is added to the spans are still valid. So you shouldn't be worried that we are talking about something that is no longer valid soon. OpenTelemetry will be the replacement, but what we did work on was based on OpenTracing. The relevant parts of the tracing standard, again, they will be valid in OpenTelemetry, are the spans. And the spans are named operations. You instrument your code, you give a name to a piece of code, and then this thing measures, records the duration of that operation. It is a very basic concept, but this is one of the fundamental parts. There is an operation that happens within a certain service, and you name it. I also highlighted the second very important part, which are the tags. Tags are mostly arbitrary key-value pairs. They are typed. They accept a couple of different types, booleans, strings, numbers, and you can enrich your operation by adding context with these tags. When I say mostly arbitrary, is because there are semantic conventions. They are actually powerful. They are strong enough for tooling to be built around it that can derive meaningful things from those tags and their values. And these are just some of examples. This is not a complete list. And we also learned that we benefit from having our own internal organization-specific semantic conventions, so it's even bigger than this. But here I'm just highlighting some of the very important ones. I'm going to highlight probably the most important one, the arrow tag. I think everyone can guess what it means. When a certain operation has the arrow tag present, and if its value is true, this means that the operation failed. If it's not present or it has the value false, the operation probably succeeded. Tools can build things around this, including measuring error rates. All of this is very important, and I have a couple of other examples here from the semantic conventions that enable what adaptive paging can do. We can use the values of all of these different things to infer meaning. I actually just mentioned it, but if named operations that record duration, arrow tags, we are using an observability instrument that gives you 3 of the 4 golden signals implicitly. You can get throughput, you can get latency, and you can get errors implicitly just by using tracing. You can get saturation because it's typically very specific to the system, but that's something that doesn't work alone, and you should be combining that with other observability instruments. And this example here is what you can observe when you have your system with distributed tracing, and you can figure out the duration of these things, and very, very important, how one operation triggers the next and triggers the next. This causality from distributed tracing is very, very important. Why is it important? Let's go a bit back to, you have your system instrumented with OpenTracing, and now you are measuring all of these things, and you have an SLO, your SLO is 3 nines, and at one point that SLO was breached by there. You created a condition for this on that particular component where the symptom, signal-to-noise ratio is ideal. You create an alert rule in there. When the place order operation is happening in this service, I want to keep an eye on this. Which means when this thing breaches your condition, you get an alert. When you get the alert, what the alert handler will do, and this is a bit vendor specific, so bear with me for a bit, because the vendor can already ship a couple of exemplars along with the alert payload, or the alert handler will have to go and query the tracing backend to query some exemplars. This does not make much of a difference. That's why we are jumping straight to, you're going to need to analyze a couple of exemplars, ideally exemplars that represent the condition. Why is this important? After you get a set of them, and you want to keep that balance between too many and you are increasing your time to page, when you have too less, and then you may be doing wrong decisions. But you will collect a set of exemplars of the condition. When you have them, and this is going to be the same process for each and every exemplar, what you're going to do, and this is exactly the example. What the alert handler does, it starts in the operation that represents the symptom. So place order in the checkout service. It starts there, and it sees the error. And what it does, it starts checking all of its child operations, all of those that are triggered by this one. Those that are not flagged as an error, we can ignore them. But eventually, we find the next one, the first child, that has the error. Okay, let's follow this one. This is, again, rinse and repeat. So now that we have found this one, which ones are the child operations? Those, we can ignore them. The logistics, the stock, the order service, they are not relevant. But we find, again, in the accounting service, doing the update account, this one also has an error. And we finally find ourselves with no more child operations flagged as an error. Well, we can already infer something here. It seems that the update account in the accounting service is the root of the breach of the symptom. Let's see this graphically. Now, if the accounting service has an outage, and we have created the alert rule there on the symptom, what do you think is going to happen now? This time, still a single page is dispatched, good, but this time it's going to be dispatched to the team that owns the accounting service. And this is very important because there is no Christmas tree effect, and we are not burning out anymore the team that owns the symptom. To make even further the point, what do you think happens if the payment service has an outage? The exact same thing. Again, a single page is dispatched, but this time to the team operating the payment service. And this actually makes the whole difference. In case you were actually paying attention to this is based on availability, for example, it's just measuring the errors, but this applies to other semantics, okay? This is just to simplify the example. We followed what represented error, a failure. But the data that we would need for all of the other signals is also present in the data, so we could look at that instead. It is different, though. For latency, in particular, is much more complex. Good. So when we did that, and we started doing this was kudos from Charity. That was excellent. Always getting some validation is good. But we did all of these things, and it was not straightforward. We were not so confident that this would work out. We faced a couple of challenges. And in case you're already thinking, this may not work for me for some reasons, probably you already think about some of these. The very simple example that I showed had a very simple path to root cause. This is not always the case. Again, the quality of the example is going to be different, and many different things can be causing you problems, okay? So one of the simple things is you have multiple paths with the error true. How we solved it is we score them. We go through each exemplar, we score everything that we found as a potential root cause, and at the end of all of the exemplars, we will consider the first one, the top number one, as the most probable root cause. Because this is a very naive algorithm, but gets the job done. And we still believe that it's still better to page 2 than everyone in the Christmas tree. So even that is still sort of reasonable. I don't personally advocate for it. Obviously, we would like to improve it, but it's still better. Another thing that we found out was, well, if you are not Google, and if you have to roll out something like OpenTracing or OpenTelemetry or anything that does distributed tracing, this can be a multi-year-long project, especially if you are aiming at having all of your organization doing it. It is tough. We don't have everything covered yet, and we started 2 years ago. But we started with the most important thing, and then we started covering the rest. By doing that, we found many situations where some service halfway was not instrumented. This is enough to break the trace. And then you find yourself with 2 distributed traces not connected. This is not okay. Basically, this is how far you can get, especially if the symptom is on only one side. To mitigate that, oh, by the way, this is also very similar to the circuit breaker. If you use it, what will happen when you open the circuit breaker to help your direct dependency to recover, what will happen is that the trace is not going to continue. But you don't want to be the root cause because you can't do anything. You're just opening for the sake of supporting the next one. But again, this is where the semantic conventions can be very helpful. This peer.service tag can help us point to the next one. who was I trying to call? There is a bit of a naughty intention in this, not just for the circuit break, which is kind of obvious, but if that team is not instrumenting their service, which would enable us all to see whatever is happening, well, now you are probably making them pay for that decision. Because we will page them until they instrument to be sure that I'm not getting paged. It works. The last part, you've probably been wondering, we just talked about identifying the operation in a certain service that is the probable root cause, is from that to who to actually page, which escalation to page, there's still a mapping that may be needed. This is also a big effort. Because when everyone is monitoring their stuff and paging themselves, they know they put themselves there. When something central such as this, the symptom that is not owned by any of them, you have to figure all this out dynamically, and now every service is eligible to be paged. And it can happen that the probable root cause doesn't have anyone on call. You cannot map it to an on-call escalation. So what do we do here? While we are traversing and finding out the next and the next and the next, we are doing this resolution of who to page. And if the real probable, well, if the probable root cause, the final one, cannot be resolved to an escalation, you still page the closest to the problem. So you go to the previous one. It's still better. We'll be closest to the problem. We roll this out with this very simplistic heuristic. It is a set of heuristics. It's a very simple algorithm. But the good part is that we started using this early this year. The number of pages reduced considerably. I actually don't have the metric for how much. But I don't know if you also suffer from high false positive rate, which is typical when everyone is monitoring on root causes. This is terrible, creates a lot of noise. And this is something that we're very proud to have reduced to 0%. So this is a metric that I'm very proud to share. 0% is the current false positive rate with this. I don't put any merit on adaptive paging, rather alerting on symptoms. So this is just validation on alerting on symptoms. It reduces the false positive rate considerably. As for the other important part, which is how much we reduce the MTTR, which I'm not comfortable to say the actual numbers, I can tell you that it was reduced by 38 times. And that's how much I can share. But we reduced the MTTR by 38 times less, which is excellent, because now by paging the right team, they are not asking questions to anyone. The actual page payload already points them at, look at these traces, and we found the problem there. They go immediately to those logs and say, okay, this is what happened, this is how I can stop the bleeding. This has been very, very important for us. How to evolve this? Because as I said, we started with something very simple that could give us value very quickly. We have that value already, but we also know that we are still in an early stage and we have 20 or something symptoms being monitored by this in our e-commerce solution. For this to survive the future, we know that we need to improve this. And we actually found out while researching that our friends from LinkedIn published a nice paper back in 2013 with something that they call monitor rank. Monitor rank is basically a concept that analyzes in real time something that could be tracing data. At the time, the tracing was not being mentioned, but now looking back into that, and if you just put tracing on top of that, it is a perfect fit. So this is something that my team is going to be looking at, and it is a very good candidate to evolve this evaluation algorithm. I'm almost done. I expect them to have plenty of questions, hopefully. This all comes down to this very important topic that is being very well present in every SREcon, and well, not even the SREcon, but it is very important for us, which is observability. Observability still has ways to go. A lot of vendors are doing great work in this front and actually innovating in this front. Tracing is also, to my surprise, something that is not widespread on every organization. Even this morning in the distributed tracing workshop, there were dozens of people there admitting that, no, we still don't do this. We have some metrics, we have some logs, or we just have logs, which is a bit surprising. And this is why I still think there is still a lot of ways to go. Ourselves, when we started this journey on the distributed tracing, we were not thinking that we're going to do distributed tracing for the sake of adaptive paging. No, this was something that we came up with afterwards. as soon as we started seeing the type of things that this new data model could give us, this is one of the examples of things that were triggered. I don't have much more, but before you get the opportunity to ask me questions, I would like to ask you a question. Are we all on the same page? Good.
Okay, let's take questions. Oh, yep, right over here.
So I really love this concept for monitoring and displaying the root cause. However, for filtering on alerting, I see two major problems with it, and I wonder if you've given them thought. The first problem is, consider the case where you have simply a front end and a back end, right? And the actual event was that a new version of the front end came out, and it is now sending somewhat different requests to the back end, and now the back end is generating errors. Now, in your model, only the back end team would get paged, whereas the correct thing to do in SRE standards would be the front end team needs to roll back their binary. And it would be difficult in that case, if they're not getting alerted, to know. The second problem I see is closely related, that even in a much longer chain of front ends and back ends, it may be the case that the error is currently stemming from far back in the back end, and the best place, the best team to understand the root cause is the back end team. But the front end is still serving errors to live users, and the front end team may have appropriate mitigations that may need humans to be involved to take place. And if they're not alerted, they won't. So are we doing nothing until the root cause gets handled? So those are two issues I see with that.
Let me try to go to the first problem, which I believe was the fault is actually being caused by a new binary on the front end. The back end is not the root cause, but adaptive paging could eventually point at the back end.
So it's not that the back end is not the root cause. The root cause may well be with the back end. It may be a bug in the back end, but that was latent until it was exposed by a change in the front end. And while it is the correct course of action over time to fix the bug in the back end, the correct immediate mitigation response is to roll back the front end.
Sounds fair, but the problem was in the back end. So this does not replace the engagement on call and teams escalating to others when they need help. It does not replace any of that. It just aims at reducing the noise and pointing to something that is believed to be the ones with the ability to solve it quicker. This is not a truism. Doesn't mean that that's always going to be the case. But most of the times that's the case. So there will be situations, probably like the exception they are considering, where their team will have to escalate to another one that to stop the bleeding right now, I would like you to roll back your binary. And that it is the right course of action. But even that could be after that backend team realized that this was a latent problem, it's going to take us too long to patch, or otherwise it's best if you roll back, which is still a decision that only they are able to do, whereas the front end probably would not understand that is something that they would have to do. There is a lot of nuances in there, I agree, but this does not exclude or invalidates all of the other best practices while doing on-call. This was for the first problem. The second, let me try to remember again.
So the second issue was, if you have an issue that the root cause is in the back end, but it displays itself in the front end, and actual users are being harmed, while the back end is in the best position to fix the root cause, the front end team may have a mitigation that's available to them and requires human action, but they need to know about it. A mitigation that they can put in place without the back end being fixed, or faster rather.
Would you consider fair my previous answer for that problem? I mean, they still need to engage with each other and figure things out. And those very particular situations, who can mitigate it faster, this should always take precedence. Because that's, right, I'm preaching to the choir, but stop the bleeding first, figure out things later. So if that's the quickest way to stop the bleeding, by all means, this is just who gets the first page. And in case you wonder, I don't think I went that deep into the explanation. Alerting on symptoms actually allows you to cover all of these things where you do the graceful degradation and all of those things halfway, which may still be hiding that there is a problem somewhere. So if the symptom is not being triggered, no page is being triggered. Well, we actually went through that, and you can put adaptive paging on the multiple layers, which dangerously approaches the other situation. The rationale is you increase evaluation time window. So here, where you have the burn fast symptom, this is where you put your focus. As you go inside, then you are increasing the evaluation time window for something like 8 hours, 12 hours, something like that. You don't want that to be gracefully degrading for more than 8 hours, for example. Good question, thank you.
Great. Oh, we'll take a question in the middle there. Yep. And then we'll take you.
So how do you handle some more broad issues like partial network outage? How do you make sure that you page infra team instead of dispatching, even if you cannot dispatch this trace because you have some network outage and you cannot page your services teams, you need to page infra team. How do you handle that case?
I was a bit afraid of that question. Obviously, this cannot address that. It can't. It can't because this is not something that those are the channels through which you propagate the context even, so this is something that we cannot address. When that happens, there is not just one symptom that is up, there will be a couple of symptoms up. The good thing about them, and this is something that we haven't done yet, but because of the semantic convention and naming operations, if everything is trying to do the same, which is very common, that points at the infrastructure, it should be easier for those 4 different people being paged for this problem. And this is also very similar for those running very large-scale infrastructure that you have a lot of software components that are proxies. A proxy succeeds when it proxies an error from a dependency. It's not failing doing its job. And if you think about the tracing and this cascading error, when the software component, which is the proxy, is in the middle, that one won't fail. That one is just proxying the bad response. So it cannot tag its own operations as failed. So this is a little bit related. This is what we found out, because this type of software is closer to the infrastructure, but it's still software that can be instrumented. So for those parts of the infrastructure that can be instrumented, we added something specific, which is we know that you are infrastructure. So they are tagged as infrastructure, which means we skip them when we are analyzing the availability. Thank you for the question.
Hi. Are you using adaptive sampling or probabilistic sampling?
So could you mind repeating the question?
Yeah. Are you using adaptive or probabilistic sampling, or are you sampling everything? Because from what I understand, it's like as if you're sampling every request that is coming through your infrastructure. And that is very expensive to do.
Yeah. In our current setup, for the important metrics, for the throughput itself, for the latency, for the error rates, all of those calculations, that time series is unsampled. For the tracing data itself, when you need the exemplars, then it is severely sampled. And we actually use a vendor. We use a commercial vendor that we avoided mentioning. But this depends a lot on whatever it is that you end up using. You can do sampling on the client side. I know, for example, I think with Jaeger, you can configure the tracer on the client side to do sampling on the client side. Well, this hinders the quality. And I don't know if they have a better solution to do the sampling on the server side that will allow them to keep the time series unsampled. It is important because it gives you better signal, but it is a very valid concern. In our case, it's not affected because the time series that triggers the signal, this one is unsampled. Then we have less exemplars, but we are lucky enough that our vendor is very good at selecting them, and they are always representative of the condition. Does that answer the question? Thank you. I think there was
So what was the cost in terms of developer time and operational overhead for maintaining the tracing system, and how did you get the business to buy into that investment?
So this question was about rolling out distributed tracing, right? So getting the buy-in was not straightforward. But we did what we consider reasonable, which was starting small, start with a group of things that have high business impact, just instrument that without my own team doing the work. We did not ask the teams to do the work. We just asked, can you please look at our pull request? So we put the work in, we instrumented a small group of things to immediately start showing the value, and this was pre-adaptive paging. This was not related to adaptive paging. This was just, we know that we need distributed tracing. But we picked that small group where we put the effort for 3 months or so, then we showed the type of value that could result in, which we're very lucky because this immediately allowed the teams, the owners of those services to identify, oh, this is why this was slow. Oh, we're doing 3 times the same. That was dumb. But now it was visible. And we collected the success stories document that then we pitched to our management to realize now it's time for us to roll this out. As I said, we don't maintain this infrastructure. We went with a commercial vendor because we sell socks. And we're not Google.
Luis, thank you for the presentation. I'm here.
Where?
In front, here, really in front of you, 2 meters.
Oh, they were too close, sorry.
Too close. I mean, the solution makes the assumption that the errors are explicit in the status codes.
Not at all. It is completely agnostic of HTTP. Was that what you were suggesting?
I'm saying you assume that the error somehow is reflected by the status code, right? So you will know that a service has failed because it has a 500 or a 0 or a -1, or is this not the case?
It is not the case, absolutely. I even dropped a statement a couple of days ago in the SREcon Slack chat because someone was asking something about that, and I gave my opinion that you should not depend on HTTP semantics for this.
No, not HTTP. Not related to HTTP, because if you are RPC, you may not have HTTP. But
exactly.
You know that a service has failed because you have an error code somewhere, or not?
It depends. The client needs to go through that. That's exactly the point with the graceful degradation. This client, the owner of this service, will decide, is this bad enough for me to consider this operation to have failed? Or if I gracefully degrade that, I consider quality, because then it's not a matter of availability, it's quality. Do I still consider the operation to have succeeded? And it's actually a benefit that you have this abstraction on the tracing model that you can tag with the error true or false, depending on this evaluation.
But the solution assumes that you have information about the services that were not executed properly.
Correct.
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 So let's map to HTTP because it's easier to map it. So if you have a 200, everything went well, and you try to find maybe a 400 or 500, maybe. What are your thoughts about a system that all the status code are always correct, but the execution of the service is not correct? So it's not explicit. So you don't know. No service will tell you I failed because I was too slow or because I had an exception. Still, what would be the approach to detect the root cause?
You just said that everything is fine.
I didn't, well, yes, from one perspective, it's true that everything is fine. But the services claim that everything is fine.
Then I don't think, I'm just trying to cut it short because we need to stop, right?
Yeah.
You can finish.
I think in your particular case, there is no observability instrument that could save you. If everything is fine, what you're just saying is that no application will report that something is wrong.
Yeah.
There is no observability instrument that can save you. My honest opinion.
We can discuss in the
Yes,
break.
yeah, because we need
more.
to switch the speaker, right?
Yes, we do. Sorry. Thank you so much. Let's have a
Thank you all.
round of applause. Thank you.